Hello, folks, and today, obviously, I'm not there. Wait, I am there in video. Ha, very good. Uh, no, but I'm going to run through yesterday's lesson for those that had to go to the Veterans Day ceremony. Feel free to pause this at any time to get caught up, but also take out your 2-9 packet from 2 days ago because it had the part 2 lesson in there. So, here we go. As you can see, today we're going to talk about reflections and stretches. Oh, sorry about that, folks. Reflections and stretches. Okay. Notice, for reflections, we're either going to multiply the entire function by negative and reflect it across the x-axis. Okay. So if I'm on a graph and I have a point here and I reflect it down, that point is going to go from xy to x negative y. Okay. So the whole y is negative. If I have a point here and I reflect it over the x-axis, I'm only going to go from xy to negative x. So the x has a negative. Okay. That's kind of the reasoning there behind these two rules. All right, and the stretches, sorry, it's kind of messy. The stretches, again, have to do with multiplying an absolute value by something, and that'll be a stretch, or maybe multiplying it by 1/2, which is a compression. Okay. Or if we multiply 1 over b by x inside. Okay. So notice, if I want to stretch, I'm actually going to have a stretch of 2 would be 1/2 x. And a compression of 1/2 would actually be 2x. Okay. So you have to, when you're doing horizontal, you really got to think about the reciprocal. All right? So let's look at some examples. This one says we're going to reflect the graph f of x equals absolute value of x minus 2 plus 3 across the y-axis. So according to our rule, if we're going across the y-axis, I'm going to go back one. If I'm reflecting across the y-axis, I'm just going to make the x negative. Okay? So my new function is going to be g of x. I'm going to make the x negative, and that's going to, so if I take a look at, and first of all, if I want to see this graphed out, I can start with what happens when I graph the original function, which is the absolute value function moved up 3 and to the right. Okay. So I'm going to take the original graph, which is right here. If I think about it, I'm going to move it up 3 and I'm going to go over 2 to the right. Okay. I'm going to take every point. One way that we can think about this, let's actually do it this way. Let's make a table of values. Okay. So if I think about my original absolute value function, we talked about 0, 0, 1, 1, negative 1, 1, 2, 2, negative 2, 2. Okay. Now, if I take those points and I add 3 to y values, 3, 4, 4, 5, 5, and I take x and add 2, 2, 3, 1, 4, 0, I now can graph those points to get f of x. So 2, 3, I'm not going to I'm just going to shade them in here. 3, 4, 4, 5, 1, 4, 0, 5. So there's my graph of f of x. Okay. Now, my new function right here, g of x, I'm going to flip this over the y-axis. So let me change colors. This point will come over to -4. The vertex will come over to -2. This point will come over to 1. This 3 will come over to -3, and that point will stay there. And there I'll have it. That's my g of x. Very good. Points, graph, equation. Next example. Sketch the graph f of x, absolute value of x minus 1, and I'm going to stretch that by a factor of 2, vertically. So when it's vertically, the rule is that your new function will be twice the entire f of x. So my g of x is going to be twice the entire absolute value of x minus 1. So when I distribute, my new equation will be 2 absolute value of x minus 2. Alright, so I need to graph that, and I'm going to use again, I'm going to take my original function x and absolute value of x, 0, 0, 1, 1, negative 1, 1, 2, 2, negative 2, 2, and I'm moving it down 1. So I'm going to take y minus 1, negative 1, 0, 0, 1, 1. And that's the graph moved down 1. So my f of x is going to be right there. And now I'm going to stretch this vertically by 2. So I'm going to take all of those y values and I'm going to multiply them by 2. So negative 2, 0, 0, 2, 2. Or I can multiply all these y values on my graph by 2. So here, 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 here. Zero, negative 2, 1, 0, 4 minus 2 is 2. So negative 1, 0, negative 1, 0, 2, 2, negative 2, 2. So when I connect those, that way, right there. And there you got it. That's stretched up by a factor of 2. And the last one, we are going to compress this graph horizontally by a factor of 1/2. So remember, what that rule says is that to get my new function, to get g of x, I'm going to take my original function, and it's going to be not f of 1/2 x, but the reciprocal 2x. So in this case, my new function is going to be the absolute value of 2x plus 2 minus 1. Okay. So I can graph this function, the original one, which is the absolute value of x, up 1, left 2. So I'm going to take 0, 0. I'm going to go up 1, left 2. 1, 1 is going to go up 1, left 2. Negative 1, 1, up 1, left 2. And I can see that this right here is my f of x in green. Now for my new graph, I'm going to take and compress all of these horizontally by a factor of 1/2. So all of my x values are going to be cut in half. So here, this point will be cut in half. 0 stays there. This negative 3 will be at 1.5. And this 4 will be back to 2. 0 stays at 0. So I can see I now have a graph that's compressed or squeezed down into 1. Today you just have a worksheet to work on in class. The sub can hand that out and you guys can get to work and turn it in at the end. Hey folks, coming back at you. I just caught one mistake. If you look up here, I said the graph moved up 1. Well, it's -1 here, which means down. So in order to keep this right, just make this change in your notes and you'll be good to go. Sorry about that. Again, you can work on the worksheet. Have a great day.